Yeah, good day and welcome to the continuation of our audio engineering course. Today we'll be talking about one of our tools, and that is audio processor, especially equalizer and also a filter. Let's quickly go on to what we are going to be learning today. One of the processor, which is equalizer, and we're going to be talking about spectrum processor, that is the one that affects the spectral balance of a signal. It's called equalizer and filter. Now, equalizer, or simply EQ, as we normally talk in sound recording and reproduction, is the process of adjusting the volume of different frequency bands. Remember, the volume or the level of different frequency band within an audio signal. That shows that we have different frequency band within an audio signal. So the circuit of equipment used to achieve this is called an equalizer. That is what we are going to treat it today. Now, the equalizer, EQ, changes the relative frequency balance of a sound. It allows different frequency range to be boosted or attenuated by variable amount. That tells you that if you insert any EQ on a signal flow, that means you are adding another gain stages into the signal flow. Nearly every channel of our mixing console has what? An EQ. And what does it is that there is a distribution, there is a separation of gain stages, at least 4 in a very good, we call it 4 mix zone. We have high, mid, low, mid, and low. Those are gain stages that we call it frequency balance in the way that we have. So EQ traditionally work by manipulating the relative phase of timing of frequency bands, causing boost or attenuation of those frequency ranges. That is what it does. That is, we can actually do what? Manipulate the relative phase and timing. The phase and timing, that is how the signal flow, that is the time of the signal flow of the frequency, and also the movement of what? Of that signal in the frequency range. Then you say when the phase of a signal is altered by equalization. Equalization is our process of altering that signal. This can have both negative and positive impact on the quality. That's the reason you have to be very, very careful. Enjoyability or psychoacoustic perception of the signal, it can change it. It can change the signal as a whole in that sense. So because the temporal phase integrity of the audio is changed. That is, if you actually wanted to equalize something, every sound, every signal has got its own natural identity. So if you use EQ, you might actually do what? You might actually change the temporal phase integrity of the audio in that. So EQ should be considered a relatively disruptive process, and its use avoided if there are other solutions. So it is not something to go to all the time. As okay, it must be used very, very carefully. If you remember reference and memory, if you use EQ anyhow, it can change the temporal phase integrity of your audio signal in that. And we'll be telling you about how to use EQ in the course of this module. Let's go on. Now, when we talk of equalizer, it is a unit, it is a device. Then equalization is a process. So what is equalization for? That is, what are we making equal to what? When you talk of equalization, I mean something needs to be equal to something. That is, what are we making equal to what in the equalization? Listen, equalization is about cutting and boosting band of frequencies with respect to other bands of frequencies. Now, I told you that we have, when we talk about spectrum, we have the low, mid, the high mid, and the low, and the high, sorry, so it's cutting and boosting of this band of frequencies with respect to the rest. So what are we making equal to what? This is a good question in that way. So to answer that question, we have to go back to history. This is how equalizer was invented. Majorly, it's not for audio engineering at all. It's not for us using the studio to produce music or something like that. Let us look at how it came into being. The earliest practice of sound engineering was when it was discovered that a telegraph cable used for sending simple electrical pulse in Morse code could be used to transmit speech over a long distance. That is the essence of telephone invention, the analog telephone invention. Because they discovered that sending simple electrical pulse in Morse code could be used to transmit speech over a long distance. So one of the problems was that level was lost over long distance. So if you are used to our analog telephone system in the olden days, there is a cable, we call it cable telephone, it's analog. There is a cable that will run from the source to maybe from Lagos to Ibadan. And each cable is actually do what? Is connected to every houses that have that telephone unit. But when you phone from Lagos to Ibadan, before the signal reaches maybe halfway, level was lost. The level was lost. And to actually combat this, to bring the level back to this original, amplifiers were placed along the way to boost the signal back up to what? Periodically. So at a certain distances, the amplifiers were actually do what? Were actually positioned along the cable. So if you look at this picture, if you look at this picture, you will see that this is like a normal, our olden telephone cable, signal cable, and you can see that an amplifier was being placed because the signal will be lost at a certain distance. Then amplifiers will be placed to boost that signal back it up again periodically. It's like a bulky black something like this along the wire. So what really happened? And this is a replica of it, one in our normal digital telephone conversation today. As you can see, in that manner, you can see when you see a telephone mast, you will see that there are a lot of these are amplifiers and everything that come with it. You see the drums and everything, the promoter, all these things comes in like that. And there is an amplifier that was used to do what? To actually boost the signal if it is lost or low in that thing. So they say, however, it was found that certain bands of frequency suffer more than the other. Certain band of frequency suffer more than the other. So the amplifier were made frequency selective to bring the response back to what? To flat. So if you have to wait, which of the frequencies that suffers more is the high frequency. The high frequency, because it cannot travel long distance. So the high frequency we do what? We suffer low. So by the time the signal gets to the destination, it will be so muddled up. It won't be intelligible. That is the reason. So the amplifier that were inside, they were made frequency selective. So to bring the response back to what? To flat, that is as it is. So every signal, every frequency will be audible. So this process was called equalization. That is the beginning of it. So the process was called equalization. So equalization now means making the output of a telephone cable equal to the input. Equal in terms of what? Frequency response. That is how equalizers were invented in that manner. Now coming to our days here, when some people started maybe in the 1960s or in the early 50s, they were trying to actually manipulate something like that through the acoustic or something like that. So they tried to look at if equalizers can be used to do what? To actually make the input equals to the output. Because of what? Because of the acoustic issues that have been given to any signal, especially the acoustic signal sound wave. That is how the equalizers were invented in that thing. Now let us look at the parameters of equalizers. What are the parameters or what are the major parameters of equalizer? Is number one, equalizer or EQ is one of the most basic yet important tools in recording live sound and all other activities of sound engineering. So equalization is used to repair problems, to make individual instrument and voice sound better. So that is what we call equals to the input equals to what? To the, or the output equals to the input. That's what we call equalization. So it is also used to improve the mix and to make tracks on a CD flow seamlessly from one to another without sudden changes in the frequency balance. Understand? So we use equalizer in different stages of audio production. In the recording, you use it to do what we want to call program equalization, to make sure that every equipment retains its identity and they are not clashing with them. In the mix, they use it to separate clashing frequencies, to separate clashing frequencies. That is what we call adaptive equalization. And also in the mastering, they use it so that every song within an album flows seamlessly without one being too high in the frequency, one too low in the frequency, or one medium. So equalization was being used to do what? To bring most of the music into what? In a very suiting and appealing manner in that way. Now, frequency and level. One of the most important features of sound is frequency. You know, sound wave has frequency. That is how many times we say occur in a second. So imagine one string of a guitar. When plucked, it vibrates at a certain rate. We've already done this one in module 3. This is frequency. The lowest string of a guitar vibrates approximately 82 times per second. So its frequency is what? 82 Hz. So we can talk of human ear can only hear a certain range of frequencies. That is 20 Hz or 20 vibrations per second. So it's about as low as it can go. So the human body can perceive frequency lower than that. Our body can perceive frequency lower than that, but it is not hearing them in the true sense, but rather feeling them in the abdomen. That is where our sub actually work very well. There are some sound that we feel. We don't hear them, but we feel it. That is the essence of sub. So the upper range of frequency that we can hear extends to 20,000 Hz, which are 20 kilowatts, that we call 20 kHz. So the reason for this is that you must understand frequency before you use equalizer, because equalizer works with frequency. It works with what? With the spectral balance, with a frequency balance of a signal. So you must understand it very well. And that is what we call frequency. Now let us go to level and decibel. We mentioned level earlier. Level is an important concept, and it could be impossible to fully describe EQ without an understanding of level. An acoustic sound has a certain loudness, which is called the amplitude at the source, which we call its level when it's gone to our electrical signal. When it is translated into electrical signal, clearly that signal doesn't have a loudness because electricity is silenced, but it still has what's called level. I hope that is clear. So when instruments are mixed together in the mixing console, each is set to a certain level. The overall mix has to be of a correct level to record onto eventually delivery medium, like CD or anything. See how the word level is used in law all the time. So we have level also in that manner. But what we are going to be talking about is the measurement. Level is measured in decibel. We use decibel because they can apply to sound and to sound signal travel or being stored in learning medium. So whether we are talking about acoustic sound traveling in the air, the signal from a microphone, or a recording on a tape, a film record, film track, etc., we can always describe level in terms of what? In terms of decibel. So these are the two parameters that are very important in equalizations. there must be a level and there must be some frequency. So if you are going to actually, and that's why in most of our equalizers, we will have these parameters there. It's very, very important. It is the level that we use to boost or to cut. We use level to boost or to cut, and we use frequency to select the certain frequency band that we want to boost or we want to attenuate. So those two parameters are very important. Let's go to the first one. The other one is audio frequency spectrum. It's called band of frequencies. That is what we call band of frequency. The audio frequency spectrum is a representation of a range of frequencies that audio devices interpret. We talked about frequency response the other time. That is what we are meaning now. So the frequency spectrum is expressed in hertz in the form of a range like 20 to 20,000 hertz, 20 hertz to 20 kilowatts, for instance. So more audio devices fall within a range of frequencies that the human ear can hear, because we use our equipment to process audio that was audio. So most of our audio equipment responds to frequencies within 20 to 20 kilohertz. That is what we are telling you now. So the audio range is traditionally divided into 3 broad classifications. This is also part of what we see in equalizers. We have the low, mid, and high. That is broad, the 3 broad something like that. But here you can actually subdivide it into several into several portions. One possible definition is that the low extends from about 10 up to 200, which is here, from 10 to up to almost about 200. The mid range from 200 to almost about 5 kilowatts here. You can see up to 5 kilowatts, and the upward, and 5 kilowatts upward to what? To the high frequency. But majorly in our mixers and everything, we have 4 mix zones, which we have the high mid, the low mid, and the low in that range. So it is possible to divide major categories into minor categories and to associate particular feelings with each categories. So whenever you are using EQ to do what? To equalize, it is very important, to identify those parameters. First, frequency. Secondly, level, and also spectrum. Those are the 3 parameters of what? Of an equalizer. Thank you very much for listening. If you really wanted to know more about our courses and to become a professional audio engineer and certified audio engineer, then call this number on your screen. Thank you very much.